Here's the answers to the practice test of chapter 10. Number 1, what's the additive inverse of negative 10.5? Two numbers are inverses with respect to addition if you add them together and get 0. So we're looking for positive 10.5 in this one. And you don't need to put a positive sign beside it. But they're additive inverses because they add up to 0. And number 2, they're inverses, but we're talking about multiplication. And numbers are inverses with respect to multiplication if their product is 1. So what do we multiply negative 5/3 by to get 1? And it would be 3 over negative 5. So negative 3/5 is the multiplicative inverse. Number 3, write negative 3/10 in another form. This is sort of a veiled way of getting at, do you think about decimals as another form of a number? So that's what I'm looking for there, negative 3/10. Is pi a rational number? Rational numbers, when you write them as a decimal, either terminate, that is, they stop, or they go on with some predictable pattern. And pi is often memorized as 3.14, but it keeps going 159, and it goes on and on forever with no pattern. So pi is an irrational number. It is not a rational number, so this would be no. Add or subtract for number 5, 6 1/3 minus 2 1/6. We can subtract the whole numbers, but we can't work with the 1/3, 1/6 until we make them the same. Basic rule of addition and subtraction, whatever you add and subtract has to be the same. So we can use a common denominator of 6 and use the equal fractions property to convert 1/3 to 2/6. Then pretty easy. 2 minus 1 is 1, 6. 2 6 minus 1, 6, 1 6, and 6 minus 2, 4. So the answer, 4 1/6. Number 6, negative 6 1/3 minus negative 2 1/6. We want to use the keep change on this one. Make it add positive. So this is add a positive. 2 1/6. So when we combine a negative number and a positive number with addition, we want to find the difference between the two. So what I really have to do is 6 1/3 minus 2 1/6. And you probably remember the answer from the other slide, but I'll go ahead and do the work on this. This would be 6 2/6, 2 1/6, 4 1/6. That's the answer to this problem, but we have to account for the negative sign. So when we do the actual problem that we were working with, it becomes negative 4 1/6, because here there are more negatives than there are positives. If you look closely, or maybe not even too closely, at number 7, you may realize this is exactly the same problem as number 6. It's just written in a different way. So we have a negative number added to a positive number, and there's more negatives than positives, so we need to find the difference between the two. I would say just look back at problem number 7. We had to go sort of like this, 6 1/3 minus 2 1/6, and when we did all that work, we got 4 1/6, and in this case it's going to be negative 4 1/6 because there's more negatives than positives. Just go back, see number 6, same problem. Working with the same numbers but different operations and symbols, we're going to do keep change to make this a pretty easy problem to do. So we're going to just modify it right here. And we could write it as 6 1/3 plus 2 1/6. We know by now that's 2 6, 1 6, 2 1/6. 2 6, 1 6 makes 3 6, 6 and 2 makes 8, and this would be the same as 8 1/2. There are 20 5/10 gallons of water in a barrel. After 5 3/10 gallons are poured out, 2 93/100 gallons are poured back in. How many gallons of water are in the barrel? And of course that means after all the pouring is done. We could represent everything that happens with addition and subtraction. Start with 20 5/10, then take out 5 3/10, it's a subtraction, and then add 2 93/100. And since we have the subtraction occurring first in this problem, that's the first thing we do. get this answer. And to that answer, we will add 2 and 93 hundredths. Careful to line up the decimals when you're doing addition and subtraction. That's the basic rule, that you have to be adding the same things, which in this problem means place value. Make sure you're adding ones to ones and tenths to tenths, etc. So there's now 18 and 13 hundredths of a gallon left in that tank or barrel. Number 10, place the following rational numbers in order from least to greatest. So we're going to focus on the least to greatest. We have to make sure we put the smallest numbers first. That has to be negative numbers first, so we're looking at the negative 3 and 5/10 and the negative 3/10. This is farther away from 0, the negative 3 and 5/10, so that's going to come first, followed by the other negative number in the list, negative 3/10. You're going to cross them out as you go. Then 0. Then we're left with 3/10, 3 and 3/10, 3/10, 3 and 3/10, 3 and 6/10. This is the one closer to 0, a little farther from 0, and the farthest from 0. So the next number in our list is 0, 3/10, and the mixed number, 3 and 3/10, and then the mixed number, or the decimal number, 3 and 6/10. Least to greatest. When you get done, just kind of go through the list, double check, make sure you didn't do something that you didn't mean to do. Make the statement true by writing greater than, less than, or equals. Number 11, negative 9 equals negative 9, and 12, negative 8 is less than positive 8. Simplify for number 13, and in this context, simplify means do all the arithmetic you can do. And this is a multiplication problem. Parentheses means multiply, so it's negative 2/3 times negative 1/4. We could do the multiplication without simplifying first, or without reducing the fractions first, and you'd get negative 2 over 12. But we prefer to look for common factors between the negative 2 and the 1 as compared to 3 and 4. And 2 is a common factor. It goes into both negative 2 and 4. 2 goes into 4 twice, and 2 goes into negative 2, negative 1 times. Negative 1 times positive 1, that we get the numerator, is negative 1, and 3 times 2 is 6. So it would be negative 1/6. 3.5 times negative 5 2/3. We've got a positive number times a negative number, so we know it's going to be a negative answer. And 3.5 is close to 4, and 5 2/3 is close to 6, but they're both less than that. So it's going to be something close to negative 24. We have to convert both of these to improper fractions, 2 times 3 plus 1, and then 3 times 5 plus 2. And you can kind of ignore that negative sign when you're doing this multiplication. Just remember that the value of this number will be a negative. 3 times 2 is 6 plus 1 is 7, so it's 7 halves. I'm going to use the X for the multiplication symbol here. 3 times 5 is 15 plus 2 is 17. And this will be negative 17 over 3. And there is no simplifying to do here. We have all prime numbers, 7, 2, 17, and 3, all prime. So we'll go ahead and do the multiplication. 2 times 3 is 6. 7 times 17 is 119. And to further simplify, remember that's a negative number. 6 goes into 119. And I don't have room to write at the bottom of the screen, but the remainder would be 5. It'd be 5/6. So just to remember, it's a negative number. Negative 19 and 5/6. When you finish this entire test, you might want to go through. One way to check is just make sure that you have all the things that are positive as positive and the negative things negative. In this case, you would just look at it and say, I've got a positive number times a negative number, so the result should be negative. Sometimes in all the math that you do, you just forget that one little detail, and that's pretty important. Negative 13 divided by 1/3. We're going to do keep, change, change to make this a multiplication problem. It's the same as negative 13 over 1 times 3 over 1. And we have a negative divided by a positive, so it's going to be a negative result. 13 times 3 is 39, and it makes it negative 39 and a 9 over 1. And you can just leave it like that, or you could write negative 39. Negative 5/8 divided by negative 1.5. I'm just going to take this one step at a time. Less likely to make a mistake. Not going to do keep, change yet, but I'm going to write 1.5 as a mixed number. It should be negative 3/2. Now I'm going to use the keep, change. Negative 5/8 times negative 2/3. And I can do a little reducing before I multiply. 2 goes into 2, negative 2, negative 1 time, and 2 goes into 8 4 times. Gives me 5 over 12. And that makes sense because if you think about the division here, first of all, it's a positive answer because you're doing two negatives. Division can be thought of as repeated subtraction, and you can't subtract 1.5 from 5/8. You can't subtract 1.5 from 5/8 one complete time. It's less than 1. When the divisor is less than the dividend, the quotient is less than 1, which this makes sense here, 5/12. Negative 7/20 times 2 1/4 can be rewritten as negative 7/20 times 9 over 4. And there's no reducing that can happen right here. We have a negative times a positive, so the answer is going to be negative. 7 times 9, 63. 20 times 4 is 80. And as long as you've checked carefully to make sure there's no common factors between the two numerators compared to the two denominators, you can be sure this fraction, the result, is already in lowest terms, which it is. 34 divided by negative 1/5. If this were 34 divided by 1/5, you'd be dividing a much smaller number into a larger number. The answer would be more than 1. So this is going to be a fraction that's not between 0 and negative 1, but it's less than negative 1 is a way to put it. So we'll rewrite this using the keep, change as 34 over 1 times the opposite of 5 over 1. So it's going to be a negative answer. 5 times 34 is 170. It would be negative 170 over 1, same as negative 170. 19 and 20 are evaluate for A as a third, B as 2, C as negative 3. One of these problems is very simple, the other is pretty complex. We'll start with the complex one, which is number 19. We have A times C over divided by, which is going to be easy or more convenient to think of this bar as meaning divided by. And this problem can be done in a more simple way than I'm going to demonstrate it. And I'd like you to think about, as I go into it, you see a point where you could say, you could have done this to make it easier. I would be proud of it if you see it, and I'll point it out at the end. So you have A times C in the numerator, 1/3, times negative 3, and I'll just put that as negative 3 over 1. Then the division bar, which is this bar right here, over AB, which is 1/3, times 2 over 1. So we're going to simplify the top part and then simplify the bottom part. In the numerator, we would get, I'm not going to put a bunch of marks in here, but we would be doing, we could divide 3 into 3 and 3 into negative 3, or you might just see this as 1 times negative 3 over positive 3, and negative 3 over positive 3, or divided by positive 3, would be negative 1. So I'm going to just put that negative 1 right there. And 1/3 times 2 over 1 down here in the denominator part would result in 2/3. So there's the 2/3. So we have negative 1 divided by 2/3. I'm going to just divide this area here. Negative 1 divided by 2/3. And this is how we want to write it to make it simple. And then we do keep, change. Negative 1 times 3 over 2, which is negative 3 over 2. And that result of that is -1.5. Okay, back to what you could have made a little simpler problem. Right here, we're using multiplication, that's important. Everything up here is the two things multiplied, not added or subtracted, and multiplication down here, which allows us to say that 1/3 divided by 1/3 is 1. Those two things can be canceled, so we can just take them out of there. And then the problem that we would do would be -3 divided by 2, which we kind of got messed up down here, but we had that down here at one point. Yeah, right here. -3 divided by 2. Sorry about that. And the simple problem, number 20, b plus a is 2 plus 1/3. Well, compared to 19, how easy can it get? 2 1/3. Solve for the variable n or x. So in the following problems, there'll be either an x or an n that you have to figure out the value for. We have 1/4 plus a number represented by n equals -3. And our choices to get the n all by itself are to either add -1/4 or subtract 1/4. And in this case, I think it might be easier, be simpler if we look at what happens over on this side with the -3, that we would do add -1/4. So we can use the same operation, but use the opposite number. I'll put it over here in like a fraction column. This is a 0 pair, so that would be 0, leaving n on the left side. -3 plus -1/4 is -3 and 1/4. And we go back to the original problem. If we would say -3 and 1/4 plus 1/4, that would be -3. N minus -3.5 equals 0. I think the first thing I would suggest you do here is use the keep change and make this n plus +3.5 equals 0. Then subtract 3.5 from both sides. Or actually you might want to think of this as add -3.5 to both sides. It's easier over here. Add -3.5 to 0. This is a 0 pair. Leaves n. And 0 plus any number is the same number you started with, so this is going to be -3.5. All kind of confusing when you look at this. You probably know it has something to do with 3.5, but whether it's positive or negative might be a little hard to think through when you just look at this. But this is the answer, -3.5. 2/3 x equals 4, which means 2/3 of a number is 4. What's that number? We find it by multiplying by 3/2. Multiplied by the reciprocal of 2/3. Make it 4/1. You can be trusted that that is going to be x. 2 goes into 2 once, 2 goes into 4 twice. 2 times 3 is 6, and 1 times 1 is 1. 6/1 equals 6. A rectangle measures 5 1/3 by 2 1/2 inches. Use the formula area equals base times height to calculate the area of the rectangle. So if you don't really need to draw it, but if you felt like it helped you visualize this problem, it's not a bad idea. 5 1/3 inches by 2 1/2 inches. You want to keep these as fractions. You could change 2 1/2 to 2.5. 5 1/3 is 5.3 repeating, so you can't get an exact value. So it's actually more convenient to keep these as mixed numbers here, at least for the beginning. So we're going to do 5 1/3 inches times 2 1/2 inches. Convert this to a mixed number. Improper fraction. 16/3 times 5/2. These are still inches. 2 goes into 2 once and then 16 8 times, which makes it a little bit easier. You wouldn't have to do that. You could get 80/6, but that's the same as 40/3. And now we have square inches, because inches times inches gives us square inches. 3 goes into 40 13 times remainder 1, and it becomes the fraction 1/3. So 13 1/3 square inches. And if you look back at the original rectangle, you can see it's a little more than 5, a little more than 2. Maybe you think of that as closer to 3, and 5 times 3 is 15. And, that's a reasonable answer, 13 1/3 square inches. This is one way that you check on this one, that you round to the nearest whole number and multiply to make sure your answer is reasonable.